podcast about the Helmholtz theorem and about potentials. So here we've written up the Helmholtz theorem, which basically decomposes a vector field into a scalar potential part given by V and a vector potential part given by A. And for the vector potential part, we have a plus sign, and for the scalar potential part, we have a minus sign. And you might ask yourself the question, why have we got a minus sign for the scalar potential part? There's absolutely no reason why that's required, but we do it for convenience. And one of the reasons is that it's just more intuitive when we think about energy and potential energy, these kinds of things, to have a minus sign here. So what do I mean by that? Well, imagine we've got the following situation. We have a hill given here, and we've got a ball at the top of the hill. We're going to designate the maximum with this dashed line here. And so if we displace the ball to the left, then we expect the ball to move to the left and roll down the hill. If we displace the ball to the right, we expect the ball to roll down to the hill on the right. Now, if we say that the shape of this hill is given by a function, let's call it v, and let's say that the horizontal axis is x, so this is v of x, then we see that it's going to move when we displace it from the maximum due to a gradient. Now, the gradient on the left-hand side, dv by dx, is, well, we can see that's positive. Whereas on the right-hand side, dv by dx is negative. Okay. So, however, if we're interested in relating the direction of motion to the gradient, this makes sense, then we see that actually the motion on the left-hand side is in the negative x direction, but the gradient is positive. The motion on the right-hand side is in the positive direction, but the gradient is negative. So we can fix that by simply saying that, well, the motion must go like minus dv by dx, so that on the left-hand side we've got negative, on the right-hand side we've got positive. Now, if it's moving to the left, then it means the acceleration is in the negative direction. And acceleration is proportional to force, it's a mass constant. So therefore we can say that f of x must be equal to minus dv by dx. And that's what we mean by the potential energy V. And this is how we relate it to the force. And this is why we want a negative sign, so that we can visualize the potential as a surface along which the particle that we're modeling is rolling. And that's really why we choose a negative sign.